Welcome back to the lesson. My name is Mr. Wong, and today we're going to be modeling the different relationships of projectile motion using a computer simulator. This is to follow on from the lesson previous, where we use a computer simulation to look at the different changes of variables and how that validates the relationships with the projectile formulas. We're going to do the exact same thing, but this time using an Excel spreadsheet. So hop on along and let's see what we can find out. Okay, so this is our trajectory, range, vertical velocity, altitude, horizontal velocity, and total kinetic energy. Now, this isn't specifically representing any projectile motion that we modeled just then, but we can put the settings in. So we had the initial velocity at about 10 meters per second. The angle of launch we had originally was about 40, but let's just leave it at 30 here, doesn't really matter. You can see my simulator has helped me break this into the horizontal and vertical components based on the velocity input I already put in. Remember, when you're doing projectile motion, unless it's launched directly horizontal, there is going to be a horizontal and vertical component in the projectile's velocity. Total displacement, 0. So what we mean by vertical displacement is equal to 0. It means that the object where it's launched will be the same height at which it falls down. Okay, so you can see how that has changed our trajectory over there. Okay, just moving back over here, you can see how the range is increasing in a linear fashion. Now, the reason why it's increasing at a linear fashion is because there is no acceleration. It's a constant velocity. That makes sense if you look at your horizontal velocity here, because if the horizontal velocity is constant, then the distance in which it can achieve in particular time intervals or in the same time interval will be the same. So that's why we get that. You can see that the vertical velocity is decreasing as we go down. So that matches with what we see in the trajectory here. So when we initially launch the projectile, okay, it's actually getting slower in the vertical direction. So the up and down direction, it's getting slower. And so that's why there is a peak point. When we reach the peak, this point here, you can see that in the corresponding location, the velocity, vertical velocity that is equal to 0. After that, the reason why this object is falling down is because our vertical velocity is also in the negative direction. So that's what you see there. Okay. And then you see a question or a diagram that shows you the total kinetic energy of the projectile. You can sort of see that it has this kind of downward dip and then it curves back up. Now, to explain why it kind of curves down and curves up, it has to do with the vertical velocity. If you recall, the formula for total kinetic energy is half mv squared. So as the velocity in the vertical component is decreasing, it is going to experience this kind of, I would assume, exponential decay. Okay, so it's decaying exponentially in this sort of way here. And then as the velocity increases, right, in this case in the negative direction, because the formula is half mv squared, the negative is squared away, and so you have this exponential increase in the kinetic energy. Now you might be wondering, if the projectile has at peak height, its vertical velocity is 0, how come we still have some type of kinetic energy? If you were just drawing the vertical kinetic energy, then yes, this would be 0. But this is talking about the total kinetic energy. And you can actually see here, the horizontal velocity at no point is at 0. So that's why there is no 0 point for the total kinetic energy of our projectile here. Okay, so hopefully that kind of gives you a nice understanding of what's happening in projectiles when it's being launched, the differences in the vertical and horizontal velocities during that launch, and also the kinetic energy differences and calculations. Obviously, part of the syllabus, you need to be aware what type of variable you will change and how that affects another variable depending on what the markers want you to investigate. So please have a go at the simulator, have a go at the spreadsheet to really check it out, and also do plenty of practice questions on projectile motion. I'm Mr. Wong, thank you for joining me, and I'll see you next time.